And thank you for joining the Calgary section SPE Young Professionals for this webinar on Bitumen Beyond Combustion. A thank you to our sponsor, Ovintiv, for their continued support of our technical programs. My name is Jennifer G, and I am part of the programs team with the YPs, and I will be facilitating this webinar. So without further ado, I'd like to introduce our speaker for today, Paolo Bomben from Alberta Innovates. So Paolo is a senior manager of clean technology development at Alberta Innovates. In his role, he's the co-lead of the Bitumen Beyond Combustion portfolio, as well as the lead for the natural gas value add portfolio. Before joining Alberta Innovates, Paolo spent 2 years in sustainability consulting at the Delphi Group. And prior to that, he was a research scientist at Click Materials, where he focused on developing catalysts to produce hydrogen and oxygen from water. Paolo has an undergraduate degree in chemistry with a minor in mathematics from the University of Windsor and a PhD in chemistry from the University of Calgary. So let's thank Paolo for joining us today.
Thank you, Jen. Can you hear me, Jen?
Yep.
Perfect. And thank you, everyone, for tuning in today, wherever you might be across Alberta or Canada and around the world. I'm thankful for the opportunity from the SPE Calgary Young Professionals to share with you today some information about our program we have at Alberta Innovates called Bitumen Beyond Combustion. This is a program that we see as a tremendous potential for the future of the province of Alberta in use of oil sands and deriving high value from oil sands. And I'm especially excited to present to the Young Professionals group because many of you, as you go through your career, if you work in the oil sands industry, may encounter this concept. Your companies may engage in this concept. You might have projects you'll run around Bitumen Beyond Combustion, so it's exciting to be able to present to this group. So for today's conversation, what I'd like to take us through is a few different topics. The first being around the concept and background of Bitumen Beyond Combustion. What is it and what's the basis for it? I'll then take us through some of the products that we've targeted as potential for high volume production from oil sands bitumen in the province. And then talk a little bit about what the next steps are. What's the path forward? How do we make this truly a reality in Alberta and derive value from it? And we'll finish off with the Q&A. And so if you have any questions throughout the talk that come to mind, please put them in the Q&A, and Jen and I will we'll go through them at the end, and I'll be happy to answer any that you may have. So let's jump right in. And I want to start off by framing the conversation we'll have today as being one that we need to change our mindset in the province. Currently, the status quo is really that we ship our natural resources, our oil, to other jurisdictions where their value addition occurs. And most producers in Alberta that aren't fully integrated don't really give much thought to what happens beyond that custody transfer. They fulfill their obligations to send oil down the pipe, and they receive their revenue from it. And that really leaves the downstream customer needs to someone else. The refineries are really deciding what the customer needs. And so I really want to challenge you today, and as you go forward, to think about that differently. Think about it as we should be really considering what the end customer needs are. And if we do that, I think we'll begin to see that significant value add opportunities can emerge if we can add that value in Alberta with our natural resources as opposed to sending it to another jurisdiction like the US for them to do it themselves. So that's the mindset and the framing I want to put around the conversation we'll have today on Bitumen Beyond Combustion. So let's dive right into what Bitumen Beyond Combustion, or as we short form it, BBC, is. And I will try to build this up from both a market pull perspective and an industry push. So let's start with what the market need is that we've identified. And that is around a growing global population. We're currently at 7.8 billion people roughly on the planet. We're moving towards 9 billion by 2050. That's 1.2 billion people we'll be adding to the earth in 30 years. And those people will need housing, transportation modes, there'll need to be infrastructure to support them, they'll need consumer goods for personal effects. All of that translates to a need for materials. And increasingly, consumers are asking for those materials to be made in a sustainable manner. So that is a clear and present and emerging market need and a market pull. If there's a way that we can fulfill that need for materials, that would be fantastic. So now let's look at the Alberta industry push. So locally, we are home to the third largest oil reserves on the planet. And currently right now, we produce roughly 3 million barrels per day of bitumen, either from mining or from in situ processes. The predominant end use of that bitumen is combustion. However, there are some non-combustion products produced by refineries, lubricants, asphalts, etc., but those only constitute about 10% of the total product slate. We also want in Alberta to find new and expanded markets for bitumen, and we're really to maximize the value. That's one of the reasons we're constantly pushing for new pipelines. But even with new pipelines, the challenges that exist with the inherent properties of bitumen will still be there. Properties I'm referring to are around composition. So bitumen is a very viscous material. That's the reason why diluent is required to be added to it for it to flow in the pipeline. It has a high concentration of metals that cause problems in refineries. It's also very carbon intense, which also requires refineries to run different types of modules to crack it and turn it into fuels. And so when you combine all those issues together, we end up receiving a lower value than we could for our bitumen on the world market. So you often hear about the discount against West Texas Intermediate that Western Canada Select receives in terms of pricing. And so even if you add new pipelines, you're still limited by these inherent challenges that bitumen has. So the question comes, is there another way that we can derive significant value from our bitumen resource, a value that is greater than what we can get by just selling it as a crude raw material? And so I'd like to propose to you now some considerations that we may want to take into account for deriving that higher value. Because if we want to derive that higher value, we may want to consider the following. Anything that's higher value, in theory, or ideally, should diversify the uses of oil sands bitumen. We should move away from just selling it as a crude product for combustion, but find diversified uses of it that are high value and large volume in the non-combustion area. And the reason why non-combustion is quite attractive is that it reduces the greenhouse gas emissions associated with bitumen use. Roughly 80% of the emissions from the use of bitumen come from combustion. And so if we can eliminate those downstream emissions, that's a win by not putting carbon into the atmosphere. Additionally, we want products that will accommodate an increasing production of bitumen in the province. We're really good in Alberta at extracting these natural resources from the ground. And we have a lot of employment tied to that. So we want to keep that going and expand it if we can. We also want to hedge against an uncertain future for petroleum-based fuels. Anyone that tells you that they know exactly what gasoline demand will be in 2030, 2040 isn't telling you the truth. We really don't know what that market will look like. And so we need to hedge against a future where petroleum-based fuels may not be in as high demand as they are today. And so we believe at Alberta Innovates that the solution to these considerations, as well as addressing the market needs globally and Alberta needs, is a bitumen beyond combustion approach, an approach to meeting local and global needs. A few slides ago, I talked about the challenges that Alberta bitumen has inherently, the high carbon content, the metals content, that lowers the value that we can receive for this product. However, in the bitumen beyond combustion concept, those what would be perceived as disadvantages are actually advantages. The high carbon content is great for producing carbon-based materials that are non-combustible. The high metals content can be translated into metal-based products or products that use metals, such as vanadium redox flow batteries. And so we've identified in a 2017-2018 study, the 4 products listed there: carbon fiber, asphalt binder, vanadium redox flow batteries, and polymers, as potential products that would require at least 100,000 barrels per day of bitumen production. As I mentioned, we're really interested in large volume products here because we really want there to be a significant impact to the province from a value perspective. So we're not really looking at the moment at niche products. We're looking at high volume. All these products would sequester carbon or greenhouse gases in their downstream use, which would be fantastic. So these are the targeted products. They're very interesting products in their own right. And I'd like to share with you now a thought experiment about how you might interact with these products in your daily life. So I want you to imagine that you're driving home from work. So this would be in a world where we're not working from home, but we're back at the office. And you have a 10-minute drive home. And so 2 minutes into the drive, you encounter a new condo construction project being made out of wood. This is becoming more common, large multi-story condo projects made out of wood. But it's no ordinary wood that's being used in this condo project. It's actually wood that's been reinforced by carbon fiber, whose origin is from bitumen. That carbon fiber is adding durability and strength to the structure of that condo, ensuring it will be a long-lasting building for its tenants, providing significant value. As you continue your drive for another couple minutes, you recognize that the road you're driving on hasn't been paved in a really long time. And that's because the asphalt that's used in that road comes from oil sands bitumen, a superior asphalt with very desirable properties. As you continue your drive, you're about 6 minutes in now, you notice that there's a wind farm with a solar array nearby. And backing up that wind farm and solar array and the energy that's produced is a bank of batteries, vanadium redox flow batteries. The vanadium used in those batteries has its origin in bitumen. So that's your third touch point now on your drive home. And finally, as you pull into your driveway, you're sipping on your iced cappuccino or your iced latte through a biodegradable straw. And the components that are in that biodegradable straw, the organic material, its origin is from bitumen. So there you go, a 10-minute drive home. You had 4 touch points with a Bitumen Beyond Combustion product. Products that are adding value to everyday life. So that's the dream, that's the vision that we have, using bitumen as a feedstock material for making different materials that add value to daily life. So hopefully that offered some opportunity to imagine how you might interact with these types of products. So I'm going to transition back to a little bit more the technical discussion and how do we actually make these products and what are the feedstocks in bitumen that would actually, what part of bitumen would actually get us to these products? So for those of you who are familiar with bitumen, you'll know that it is not a uniform mixture. It's not a single molecule that makes up bitumen. It's actually a wide range of molecules. And the component molecules that are of most interest that we see as having the most promise is called the asphaltenes. This is the heaviest component of bitumen. It's also the component that necessitates the use of diluent in the pipeline. This is the component of bitumen that makes it so viscous it doesn't flow. And so 15 to 20% of bitumen is asphaltene, so it's quite a substantial amount. So if we can, instead of sending it down the pipe, we pull it out and use it for making different types of products, we see significant potential value coming from that. So what's so special about these asphaltenes? Why do we see them as having high promise for making products? So asphaltenes are actually not a single molecule. They're actually a broad range of molecules with wide range of weights and different types. They're primarily carbon, roughly 78 to 80% is carbon, with the balance of the molecules being a combination of hydrogen, sulfur, oxygen, nitrogen, and various metals. It's a solid at room temperature, which makes handling a lot easier than if it was a liquid or a gas. It's also thermoplastic, which means you can heat it up and cool it down and bring it back to its original state. And it has a wide range of softening point. There's no defined melting point, again, because there's this broad range of molecules. For those of you who are more visual and like to visualize these molecules, they look something along these lines. So these are some examples of types of molecules you might find in the asphaltenes fraction. But what I really want to highlight here is that you have these ringed structures. And I'll come back to this later when I talk about carbon fibers, but ring structures are really useful in the formation of carbon-based materials because it reduces the energy required to make those materials. So you have a lot of ring structures. There's some sulfur and nitrogen blended in. You might find metals as well, but essentially it's a wide range of different types of molecules, but most of them will have these ring structures. And they're essentially a great building block for the type of products I'll talk about in the next few slides going on. So that's a quick snapshot on the background and the types of feedstocks that we would use. I now want to transition into the products. And I want to start with asphalt binder because that's the one we see as really having the near-term opportunity for making an impact in this program. So asphalt binder is a material that is very common. You'll encounter it on a daily basis, whether you're on the road or on a tennis or basketball court. You likely have asphalt shingles on your roof. All that asphalt is held together by this binder material. It's a very sticky material that keeps all the pieces of the asphalt together, the aggregate and other components. It's primarily sourced from petroleum, although there are some natural sources of it. Globally, asphalt binder is a large market because everyone needs roads to drive on and roads to bike on, and people have homes that need shingles. Roughly 100 million tons a year worth of asphalt binder is sold, a $50 billion market. There is strong and growing demand in Asia, especially with China's new initiative to the Silk and Belt Road Initiative, as well as initiatives in Southeast Asia to increase the middle class in those countries. And so there are a lot of global suppliers for asphalt. I've listed a few here. Some of them are North American companies. Asphalt binder is a product that sells at a premium over benchmark crude prices. I've seen prices in the last year between $75 to $115 a barrel for asphalt. And based on those prices, it's not surprising to see companies now in Alberta starting to take another look at asphalt and whether it's a product that they want to produce out of the oil sands. One of the challenges, though, with asphalt binder, and one that really fragments the market into a regional one, is that it is currently shipped in molten form. So it has to be hotter than 150 degrees Celsius, and it takes energy to actually heat, the asphalt and keep it at that temperature. So that really restricts the market to being a regional one. But we think that there's an opportunity with some technological innovation to break out of that regional market and really make a global market for asphalt. And I'll touch on that in a couple slides. So how is asphalt binder made? How do we actually get to produce asphalt binder? Conventionally, with conventional crude or heavy oil, asphalt binder is produced in a really, I would say, simple approach. It's essentially put through the two towers in the refinery. The atmospheric tower, what doesn't fly in the atmospheric tower, is then passed on to the vacuum tower. The vacuum distillation tower, then what is left over from the vacuum distillation tower and it does not distill, that component that did not distill is then air blown and treated with some different processes to make asphalt binder. It's then stored and ready for market. If we wanted to do this with oil sands bitumen, the process is almost identical. It would again go through the atmospheric distillation tower and then the vacuum distillation tower. And then what's left over in the vacuum distillation tower that did not distill would then be subjected to air blowing and other proprietary treatments to make asphalt binder. And so the great thing about this is if we want to expand our production of oil sands asphalt binder in the province, we don't need to reinvent the wheel in terms of technology and what needs to be done. The technology already exists to incorporate oil sands bitumen for asphalt production. And that's a significant benefit. But for producers that don't have refineries or aren't fully integrated, there may be some hesitation because it's really expensive to build a refinery. So what other types of opportunities or challenges then exist to getting those types of producers, the small scale bitumen producers, or maybe the larger scale ones without a refinery, how do we get them involved in terms of producing asphalt? So one of the challenges that we're addressing right now is that a lot of these producers really may not know how good the asphalt from Alberta can be. The large players, the Imperials and the Huskies, do know, but some of the other participants in the Alberta bitumen producers probably don't know. So we're running a study right now, Alberta Innovates is, with a professor out of Queen's University, an expert on asphalt, to benchmark the quality of Alberta oil sands asphalt binder. And what he's identified thus far is that asphalt binder from oil sands is superior to almost every other binder in the world, with the exception of that comes out of Venezuela. We're familiar with the crisis in Venezuela right now in their oil sands, or their oil industry, their heavy oil industry. So this is a real opportunity for the Alberta oil sands asphalt binder to showcase its superiority to different end users around the world. So we're really excited about that study. The final study should be released early next year. The second opportunity is around producing asphalt binder at an intermediate scale. So instead of requiring an entire refinery, can we produce asphalt on 1,000 to 2,000 barrel a day of bitumen level? This would enable small producers, those who have oil sands operations around maybe 5,000 barrels a day or 3,500 barrels a day, to participate in this market. And we see those players as having a significant potential opportunity to enter this market if this type of technology is developed. And also developing this type of technology and allowing them to sell into the asphalt market might make their operations more economic, enabling them to continue to operate them or start up operations. And finally, one of the really big opportunities we see is the ability to break out of this regional market and really reach the global market by moving asphalt binder long distances at ambient temperature. Right, as I mentioned, right now, asphalt binder is moved hot, and it's really restricted to a regional market. There are some ships around the world that can move asphalt binder hot, but they're limited in number, and it's quite expensive to keep it operating or keep it at a high temperature, similar with rail. And so we really want to break out of this, and what we would really like to see is some sort of technology that can pelletize asphalt and integrate it with our existing infrastructure systems. So, for example, train cars move coal quite readily in hopper cars. Instead of moving coal, we could imagine moving asphalt binder in those hopper cars and then using the coal terminals at our ports to put it onto ships to then be sent around the world. This would require a large volume pelletization technology to be developed, but we see this as the real opportunity in this space. And there are some industry parallels to this that are out there. So NETEC Corporation out of the United States has proposed asphalt binder pellets that are coated in polymer and minerals. However, that type of arrangement would require the end user to remove the mineral prior to applying it for use as asphalt. Closer to home, some of you may have heard of the Canapux technology developed by CN and Innotek Alberta. That technology was designed for raw bitumen, and essentially bitumen is put into this yogurt tin that is made of plastic. You can envision then a potential parallel where instead of putting bitumen inside, asphalt is placed inside. And that would actually be quite advantageous because for those of you who may not be familiar with asphalt and how it's put together, plastics are often used as an additive to making roadways in certain parts of the world. They call it polymer modified bitumen. So if, in the Canapux example, if there was asphalt on the inside, plastic on the outside, the end user would just then have to blend it together, and then they would be readily able to put it down onto the roads. No additional work would be required. The other technology I'd like to flag to you is around Solidium's solid asphalt pellet transport. Solidium is a local Calgary company spun out of the University of Calgary, and they make pellets that look similar to what you see on screen right there. And so that's another technology that's looking to try to move asphalt long distances at ambient temperatures. So I'm really excited about this the space around asphalt binder. I really think that in the next couple of years, we're going to see asphalt binder from the oil sands be viable to be sold overseas through one of these methods of long distance ambient temperature transport. So really stay tuned on that one because I think it's really exciting what's happening in that space. So from asphalt now, I'd like to transition to vanadium. And so vanadium is a metal. It's one of the metals found in bitumen. It's an important metal used globally in metal alloys. It's also used as catalysts. But where we really see the opportunity in the next coming decade and few decades is around flow batteries for energy storage. So large-scale energy storage, variable electricity sources such as solar or wind, there's a real opportunity given the large proliferation of solar and wind that is here today and upcoming. In bitumen, vanadium is quite concentrated, approximately 200 parts per million. It's one of the higher end concentrations for vanadium found in deposits around the world. And if you can remove vanadium or other metals from bitumen, it would make the refiners and upgraders really happy. If you can develop that technology, you'd probably be able to retire early because you'd make a lot of money from it. Because the metals foul up the refineries and the different processes in the refineries. So if they can reduce the metal content, that's always something that they're looking towards doing. But what are the challenges then with vanadium? Why hasn't this happened yet? Vanadium, unfortunately, is held very tightly in those organic molecules that I showed you earlier. So from a thermodynamic perspective, it's very difficult to remove the vanadium and other metals, in fact, from bitumen. So that's one of the opportunity areas. So if anyone has any innovative ideas around extracting vanadium, I'd love to have a conversation around that because that's certainly something that we're always looking for a solution for. The other opportunity and challenge is around the operation of these batteries in Alberta. And we have a couple studies underway right now that are looking at that to see what the viability is of these batteries in our climate. Our climate is quite unique. We have large temperature swings from winter to summer. And so we're investigating that as well. So those are the two big opportunities around vanadium. And I think the vanadium, if the extraction piece can be solved, I think we're looking at a timeline probably in the next decade where we're starting to reap the benefits and value from this opportunity area and this product area. So that's all I wanted to share on vanadium. I'll shift over to polymers now and give you a couple slides on that. Talk about what the opportunity area we see with this product. This one is more of is more of an aspirational area, one that we see as really having a large potential opportunity. The use of polymers is growing despite what you hear in the media and despite what some of the malignment that polymers get. 1.2 billion additional people on the planet, we're going to need more polymers. It's a large market today and growing, and so if we can capture that by making polymers from bitumen, there's a significant opportunity there. Now, the real challenge though comes into what type of polymers could you make from bitumen? Polymers are typically repeating units of the same component. So for example, you may have heard of polypropylene. Polypropylene is repeating units of propylene. Polyester is repeating units of esters. The challenge with bitumen and the asphaltenes in particular is that the asphaltenes don't have really repeating units. They're sort of this broad arrangement of organic materials. So it's really hard to develop these sort of repeating systems that we have in common polymers. However, our curiosity is in this area is, could you make polymers that don't have those repeating units, but still give you the performance, cost, biodegradability functions, environmental benefits that you get in a regular polymer? So is this an opportunity area that we could take advantage of to make polymers from bitumen? If we could, we think the market could be significant. And certainly we want to find a way to make these polymers biodegradable so that their environmental impact is minimized. So that's the real challenge around polymers, and that's really all I'm going to say around polymers, because it is what I see as the really long-term opportunity out of the four products that I'll talk about today, because there's just a lot that has to be done from a scientific and engineering level to get us to where we need to be. Okay. So I've gone through the asphalt binder, vanadium, and bitumen, and now I want to talk about the last product on the list for today, and that's carbon fiber. And those of you who may be familiar with Alberta Innovates and been following us on this topic will be aware that we talk a lot about carbon fiber, primarily because it's one of the big opportunity areas. and for us, it's one of the most exciting opportunity areas. Carbon fiber, for those of you who are not familiar, is a building material. It's a building material that has excellent strength and durability properties. It can be used on its own and woven into fabric, like you see on the left-hand side of the screen there, or it can be used in composite materials with plastics, woods, cements. So for example, if any of you have ever flown on the Boeing 787 Dreamliner, that plane has a large component of it as composites with carbon fiber. Okay, it's one of the reasons that aircraft can now have humidity levels much higher than just an aluminum-based aircraft. Other uses of carbon fiber, it can be used in different types of, in rims, in bicycles, but the common theme in all of these is they're high-end, high-priced applications. And the reason for that is that the cost to make carbon fiber right now is quite expensive. But we think we can lower that with bitumen and asphaltenes, and I'll get to that in a few slides. But because of the high cost, the current production is quite small, 80 to 100,000 tons per year. If you compare that with steel, for example, steel production is 1.6 billion tons per year. So it's got a long way to go to catch steel, but that's okay because that's a growth opportunity that we see that we could take advantage of. Carbon fiber comes in many shapes and forms, so you can find it wound up on a spool. It can come as a sheet, as you see there in the middle, or it can be chopped into small pieces, like on the bottom right there, and then put into composite materials. How is carbon fiber made? There's two feedstocks that are commonly used for carbon fiber today, polyacrylonitrile, or PAN, or petroleum pitch. I'm not going to talk about pitch because it only makes up about 5% of the market, but I'm going to focus on polyacrylonitrile, which is the other 95%. Polyacrylonitrile is made from petroleum, in fact. So natural gas liquids are cracked into propylene. Propylene is then mixed with ammonia, which then forms acrylonitrile. That acrylonitrile is then polymerized into polyacrylonitrile. That process to make polyacrylonitrile constitutes roughly 35 to 40% of the total cost of this process. The remaining costs of the process involve the spinning of that fiber and then the heating processes. Now the heating processes have the names of stabilization, carbonization, graphitization, but all that really means is it refers to the different temperature ranges that occur in those processes. So stabilization is 400 Celsius, carbonization is 800 to 1500 Celsius, graphitization is over 2000 Celsius. So these are very energy intensive, high heat processes to make carbon fiber. It's a commercial process. It's also complex and costly. So here's an image flashing up on your screen right now of what a line would look like or a train would look like in an industrial facility. This is courtesy of Oak Ridge National Lab in the United States. You can see from the top diagram all the spools and all the fiber lines that are going into those spools. This is very much a textile-driven process because it was developed by those in the textile industry. But because PAN is a textile. However, we're now starting from a different starting point in terms of asphaltenes. And we believe that the processes to make carbon fiber can be disrupted to help bring down the costs and expand the capacity for each line. So what would it look like from bitumen? So from bitumen, what we would start with is we would put it through a solvent deasphalting or partial upgrading process. That will split the bitumen barrel into the light petroleum fraction and asphaltenes. The light petroleum will have an API around 20 degrees, and it can be put into a pipeline without diluent. The asphaltenes then would go through a process that you see there on the screen, and that process is currently undefined. There's a real opportunity for innovation here, okay, down this process line to really reduce the cost of the overall process. The reason why we're interested and we think there's an advantage to using asphaltenes, it has a favorable chemistry. Remember I mentioned earlier that it already has those rings made? Well, but the formation of rings in the carbon fiber process is one of the most energy intensive parts of the process. And so if we're already starting with a lot of those rings made, it should reduce the energy and therefore reduce the cost of the process. Asphaltenes, comparatively to polyacrylonitrile, are quite low cost, and that should be a real benefit. It'll also divert hydrocarbons away from combustion. The challenges with innovating this process is that we really don't understand the scientific and engineering fundamentals. We're still working towards that. The process technologies are still to be developed. We could use the standard process that's used for polyacrylonitrile, but there's an opportunity to really rethink that with this new starting material. We're not sure of the impacts of the high sulfur and metal that is found in the asphaltenes. That remains to be determined, what impact it will have, whether we can scale up those processes. Ideally, we'd like to do that to make it more efficient on a scale basis. And we're still not sure about the carbon efficiency and greenhouse gas impacts of this process. So there's still a lot to establish here and determine, but really offers the opportunity for any innovative minds out there to join us to help solve some of these challenges. I talked about the price and why the price is so exciting to us. And so here's a little bit more on that. So currently carbon fibers sells for $8 to $16 a pound US, or roughly $18 to $35 a kilo. The target for large-scale automotive use by the Department of Energy in the United States is $5 a pound. Polyacrylonitrile starts at $3 to $6 a pound. And we know that that's only 40% of the cost. So if you're starting at that cost basis, there's no way you can meet the $5 target. However, asphaltenes would at most sell for asphalt price, which works its way out to roughly 24 cents a pound at the most. 24 cents versus $3 to $6, we have a lot of wiggle room to get to that $5 target. That's one of the reasons we're so excited about carbon fiber from asphaltenes. We also know that the market should be there. The global steel market was 1.6 billion tons in 2016. If we only take 1% of that steel market, and I'm only talking about steel here, I'm not even talking about aluminum or copper or any of those other potential applications, just steel, it would require 500,000 barrels a day of asphaltenes, or 2.5 million barrels a day of bitumen. So could you imagine 87% of our current production of bitumen being diverted to produce carbon fiber? Can you imagine the significant value add that could have to our province, right? So that's why we're excited on the market side. On the dollar side and the value add, here's where our math is at. And so this is the third part that makes us really excited. If you started at $30 a barrel for bitumen, and this is a revenue, not a net back after operations, but a revenue. So if a barrel of bitumen sells for $30, and then you split it, as we need to isolate the asphaltenes, the de-asphalted bitumen would then sell for about $35, and your 85% of the barrel would go to that. So you're still roughly around $30 in terms of value. The asphaltenes would be a negative value right now because there's no real use for them. You'd have to pay to get rid of them. However, if you sold them to a carbon fiber manufacturer at around asphalt price, which is 52 cents a kilo, then you'd get about $12 for it. So we've taken the barrel value from $30 to 42. Now, if we can capture the production of carbon fiber in the province, carbon fiber sells for around $10 a kilo. And I've lowballed this compared to current prices, but I'm assuming that we're going to bring the price down by using asphaltenes. But at $10 a kilo, now we're getting $143 a barrel for that carbon fiber. So the total value has gone from $30 to $175 a barrel, almost a 600% increase if we can capture that all in the province. And at the scale we're talking about, this could have significant economic benefits for Alberta. And not just in the production of carbon fiber, okay? We have the potential to create a clean 3D printing manufacturing industry in the province because we now have this new building material that's readily available and cheap, all right? We think making carbon fiber from bitumen will have a lower greenhouse gas intensity. We also think that carbon fiber can reduce GHG emissions globally. If you put it in a car, it will it'll increase the energy efficiency and the fuel efficiency of that vehicle, reducing fuel use. So there's a lot of downstream benefits from potentially making and using carbon fiber. And that's why we've launched a carbon fiber grand challenge. this grand challenge is putting $15 million towards accelerating the development of carbon fiber from bitumen. We're in phase 1 right now of a 3-phase, 4-year competition. And by the end of 2024, we hope to have commercially investable technologies ready to go. And so that's, we're really excited about this. And so I just want to finish the carbon fiber portion of the talk by just saying, we really see this as a strategic opportunity for Alberta. People have been looking for an alternative feedstock for the last 20 years. We've been told by carbon fiber executives in the US that what we've been able to do thus far in the last 2 years at the University of Alberta has leapfrogged the last 10 years and $50 million worth of efforts that the US Department of Energy has done. So they're really excited that we're on the right track. It could be a real strategic opportunity for us. So that's it in terms of products. So we've talked about asphalt binder, vanadium, polymers, and carbon fiber. Now I just want to talk about what the path forward is. Where do we go from here? Alberta Innovates will continue to invest in these types of projects to advance innovation. We're currently funding 9 projects at an aggregate cost of $4.4 million, half of that being our funding. And more projects will soon emerge as part of this carbon fiber grand challenge. We'll be investing in projects that address the overarching challenges for Bitumen Beyond Combustion, namely, developing innovative and large-scale processes for these products. We're really curious about understanding the end of life. We don't want to just make products that will create more waste. We want to make products that are recyclable, reusable, and add value, right? We're also interested in understanding what the GHG emissions reduction benefits are by sequestering the carbon in these products, as well as finding low carbon emitting energy sources to power these manufacturing processes in the province. These are quite the challenges that we have before us in this program, but I really want to reflect back on where we've been in this province. We've done this before, but we can do it again. We did it with SAGD. SAGD took 20 plus years to develop, and I don't think any of us would argue that the benefits from that was not worth it, because the benefits that have come out of that process are significant. It was very challenging from an engineering perspective. It was all subsurface. This BBC challenge is all above the surface. And so it should be easier and it shouldn't take as long. And so we truly believe that this could be the next significant SAGD type opportunity for Alberta's oil sands and petroleum industry. We can do this. So what I want you then to take away from this talk once we end the conversation today is really to think differently. Think beyond the current paradigm of how we derive value from our oil sands bitumen. Understand that bitumen is a special feedstock that contains a lot of the essential components to making high performance carbon materials that a growing global population needs. We're trying to meet a market demand from a growing global population here. There's significant value uplift to making these products, and that we can do this, but we need everyone's ideas and ingenuity to be brought to bear to these challenges. Every one of us on this webinar can contribute to this initiative and this concept. And the time is now, not 10 years from now, not 15 years from now, today, to really to set this up so that we are reaping the benefits of this 5, 10, 15, 20 years from now, and continuing to benefit and maximize the value of our natural resources in this province. So I just want to finish off by acknowledging that some of the images in this presentation I took from publicly available websites, and so I want to gratefully acknowledge their use and that they're restricted to the use in this presentation. And I want to thank you for your attention today. I'd be happy to answer any questions you might have on this topic. So thank you, everyone.
Thanks, Paolo. That was a very great talk with a lot of good content in there. So I look forward to seeing how all of those products progress over the next couple years or decades. So we have quite a few questions that have come in. So I'll start with one of the questions we kind of first received. How will the current downstream companies adapt or compete if there is a new market entrant with the BBC products?
So presumably this is referring to the refining companies or companies that have refining operations. So certainly there will still be a substantial amount of bitumen that will be diverted to combustion fuels or to refiners. So roughly 80 to 85% of that barrel is still going to go down the pipe to a refinery. But I think if we can take out the asphaltenes component of it, that adds a lot of benefit to those downstream companies. It reduces their costs of refining because now they're not needing to deal with a lot of the impurities and a lot of the materials that cause challenges to them in the refinery. They may have longer life for their catalysts and they may reduce the amount of turnovers that they need to do on their refineries. So there'll still be a lot of benefit for those downstream companies in terms of bitumen or fuels to be produced from their refiners and product slates. And we're also, in a way, providing a benefit to them by eliminating some of the challenges or challenging components of bitumen that they have to deal with in their refiners.
So to follow that, if asphaltenes compose 10 to 20% of bitumen, what composes the remainder? And are there any non-combustion uses for these components?
So the remaining components, so I sort of glossed over what asphaltenes really are, in that they're a solubility fraction of petroleum. So essentially whatever doesn't dissolve in an alkane like pentane, but does dissolve in toluene, that's an asphaltene. And so depending on how you cut it, what's left, you'll probably have long chain hydrocarbons. You might have some resins in there, as well as some saturates. And so those components, you could potentially make probably some lubricants out of those. You wouldn't be able to make any asphalts out of those. So there are some non-combustion uses for those products in the current refinery slates. However, it's not as much as if you had the whole barrel combined.
Interesting. And how does the emissions and the land usage intensity of the asphalts and the vanadium extraction for BBC compared to other extraction methods?
So the vision really around how do we get these asphaltenes, we're really looking at partial upgrading as the primary approach to producing these asphaltenes. And so there are a few companies right now in Alberta that are exploring partial upgrading quite seriously. I'm not familiar with the footprint of a partial upgrading facility. However, I would imagine it would be on a similar footprint to current upgraders today. So yes, there will be some land footprint associated with developing the processes and the facilities to isolate these on a large scale. And that's something that we would just have to manage and mitigate any potential environmental impacts from.
Yeah, definitely an important consideration. Do you think asphaltenes could be removed at the battery or the cleaning plant? And could this reduce the amount of diluent needed for transport?
So asphaltenes, in theory, you can remove them at the battery. However, the way to remove them is actually to use a significant amount of solvent. So typically the ratios are 40:1 solvent to bitumen. So this is a substantive amount of solvent to be used. To put a solvent deasphalting unit on every single battery or every single output source might be a little cost prohibitive. And so I envision more centralized locations or centralized processing facilities to be more economic in that respect. In terms of reducing the need for diluent, in theory, once you've removed the asphaltenes fraction, the remaining oil should not require diluent. It should be able to free flow through the pipeline. So in theory, if you remove the asphaltenes and you remove the diluent, you open up 40 to 45% of pipeline capacity. on the heavy lines, in theory. So certainly by removing the asphalt, it would reduce or eliminate the need for diluent to transport the remaining deasphalted oil.
Who would you say, and this is asking where as well, is the prime competitor for the carbon fiber development?
So there's pockets of carbon fiber development and expertise around the world. Certainly the United States has been pursuing carbon fiber from coal tar for the last probably decade. They've also done a deep dive into lignin, which comes from biomass, and they've been unsuccessful. But there's a lot of expertise built up in the United States along those lines. The Japanese, the Koreans have significant expertise in making carbon fibers from coal tars, petroleum pitch. The Chinese as well have a lot of expertise in this area. There's some expertise as well in Germany as well as in Australia on this topic. So yeah, it is a global research field, and there is also a little bit of care to be taken because carbon fibers are actually in many of these countries national security products, and so there's a lot of care that's taken in terms of what type of information can be shared on carbon fibers, but those countries in particular have pockets of expertise.
Okay, I'll just ask a couple more questions here. Does Alberta have a near-term target for bitumen diversification? Is there a percentage of the total bitumen produced that is being targeted?
To my knowledge, the province doesn't have a specific target for diversifying bitumen into different products. There are research and innovation targets set by the province that are looking to increase the value of our oil and gas resource. And so that is sort of tied into that. But there isn't, to my knowledge, a specific target that the government of Alberta has set saying we want 20% of our bitumen to be non-combustion products or diversified product base. Again, typically the product slates are determined by the refiners depending on their customer needs.
And then are there any efforts looking at using asphaltenes as a feedstock for the graphene production?
Yeah, so we actually have a project that's exploring the use of asphaltenes for graphene-like materials. It's not, I would say, it's an interesting area. It's not as high a priority area for us because graphene is one atom thick. And so from a volume perspective, we're trying to target 100,000 barrel per day high volume products. It doesn't really fit that criteria. However, there is current exploration at the U of A, University of Alberta, looking into that very question.
Mm-hmm. And because there's such value that you showed for these products, why are there no commercial projects yet for these?
So I think it's two parts to that question, two-part answer to that question. One, I think, is around the technical know-how or the innovative process solutions haven't been developed yet in many cases. I highlighted what the challenges are, and those are still in flight, trying to resolve those challenges. So I think that's one piece of it. And I think the second piece is this idea of using carbon materials for products is still relatively new to a lot of people in industry. And so wrapping people's heads around that this is something we can do and that it potentially has high value is something that I've been really trying to push for in the last 2 years, trying to really get people on people's radar so that they begin to think about this, so that it moves up the chain to the decision makers who can then make decisions that will enable these types of products to be made and to be part of the supply chain for their companies. So I think it's still early days, but momentum is building for the future.
Yeah, that's a fair answer. Okay, there are quite a few other questions, and for anyone that didn't get them answered, I'd encourage you to reach out to Paolo. I'll close with this question. Besides Alberta Innovates, which other organizations do you know of that are doing research or projects on the petroleum beyond combustion?
So the organizations that we fund, so for example, CanMet Energy Devon, that's a federal research lab. We have projects at the University of Alberta, at the University of Calgary, at Queen's University. There's some expertise on asphalt that we've tapped into. There's some expertise in concrete out in Victoria that we have a project with. But primarily the academic institutions in Alberta right now are the ones that are taking the lead on this because it is still early stage. I think as we move forward in the next couple of years, what we're going to see is a lot more companies starting to get involved in these projects. We've made a deliberate effort to get those companies involved as advisors on these projects, like the large-scale oil sands companies, to get them involved in these projects so that they're aware of what's coming, so that they can begin to plan for the future around these opportunities that are emerging. But right now, it is primarily the domain of academic institutions.
Great. Well, thank you so much for your talk today, and look forward to continuing this discussion over the next couple of years. And I'll let everyone sign off and continue on their day. Thank you for participating in this webinar with us.
Thank you, everyone. Thanks, Jen, for the opportunity.